All right, so I'm going to talk about Unit 9, and Unit 9 says surface area and volume at a glance. But to be honest with you, because of the times we are in right now, we kind of shortened this chapter just because of the remote learning. So we're not going to talk about surface area. We're really just going to talk about volume. So the first thing is that we need some vocabulary. So three-dimensional shapes are called solids. When a solid is formed by polygons, the solid is called a polyhedron. So when the sides of something are polygons, it could be called a polyhedron. For instance, if I take a look at this calculator, right? This side is a rectangle, roughly. I know the sides are rounded, but let's just pretend it was straight. That would be a rectangle. Then this side here would be a rectangle. This side here is a rectangle. This top is a rectangle, and this bottom here would be a rectangle. So all the sides are polygons, so it would be a polyhedron. The plane surface of a polyhedron are called faces. So again, if I use my calculator, this is a face, this side is a face, this is a face, and so on. Segments joining the vertices of a polyhedron are called edges. So again, back to my calculator, it's kind of obvious. This here is an edge. It joins this face and this face. So right here would be an edge. This would be an edge. It's really basically what you would think an edge to be. The two bases of a prism are congruent polygons in parallel planes. And we'll talk about that when we talk about prisms. And the base of a pyramid is a polygon. And again, when we talk about pyramids, we'll talk about that. So there are 5 basic polyhedrons, and that's not exactly true. A prism, a cylinder, a cone, and a pyramid are polyhedrons, but because a sphere, the face of a sphere isn't really a polygon, it's not really considered a polyhedron, but it is one that we will be talking about. So these are the 5 that we will be talking about. So let's take prisms first. So by definition, a prism is a solid geometric figure whose end bases are similar, equal, and parallel, and whose sides are rectangles. So let's first just kind of think about what that's saying. So let's just take this first one here. The two end bases are similar. So this base here and this base here, those would be similar triangles. They're going to be equal, so they're going to be exactly the same size. They're parallel to each other. And all the sides going around, so the sides that join those two are all rectangles. So you can see this is a rectangle. If you look at this one back here, this is a rectangle, and so forth. And that's true of all of the prisms. So this base here and this base here, you can see that they are parallel. They are exactly the same. And everything going around joining those two bases are rectangles. Same thing here. We've got a rectangle and a rectangle. They're pyramid. They are parallel, sorry. And going around these sides here are all rectangles. A prism is named by the shape of their bases. And notice that there are 2 bases. So this here and this here is a triangle, so this is called a triangular prism. This here and this here is a pentagon, so this is called a pentagonal prism. And this here and this here is a rectangle, so this is called a rectangular prism. So the biggest thing to kind of note is that prisms will always have 2 bases that are parallel, and everything else will be a rectangle. Cylinders actually have some very similar properties to prisms because they also have 2 parallel bases that are exactly the same shape. So this one here would be a circle, and this one here would be a circle. And if I actually opened this side up, it would be a rectangle. So if you kind of think like a soup can, if I took the label of a soup can off and kind of stretched it out, that's what it would look like. So this side over here, if I kind of peeled that open, it would look like a rectangle. The things that are important about a cylinder is because this is a circle, we would have a radius of a cylinder. We could also have a diameter. So if you remember, the diameter would go all the way across. So a radius would be half of the circle, and the diameter would be all the way through the circle. The altitude or the height, right? That's going to be, how high is your can or whatever it is you're talking about. And again, the 2 circles are your bases. The next polyhedron is a cone, and that one's kind of obvious to us. It's just like an ice cream cone. And the biggest thing that's different now between a cone and a cylinder is a cone comes to a point, which is called the vertex. Again, they have one base now, not two, and the base is still a circle, just like a cylinder, and it can have a radius or a diameter. A cone actually has two heights that we call. The one here that tells you how tall it is, it kind of goes from the middle of the circle up to the vertex. That's called your height. And then this side one is called your slant height. Slant height is used when we're going to be calculating the surface area, which we're not going to be doing this year. So you don't really have to concern yourself too much with the slant height. A pyramid is a polygon that has a base. So again, this will only have one base and three or more triangular faces that meet at a point. So now each one of the faces is going to be a triangle. So, and this point here is called the apex. So your base can be any shape. This could be a square, it could be a triangle, it doesn't really matter. And just like a prism, a pyramid is named by its base. So if you take a look this here, this is a rectangular pyramid. Or if you knew for sure this was a square, you could call it a square pyramid. Like if I had marked that this, and this were all congruent, then you could say it's a square pyramid. But you would need to have markings to know that it's a square pyramid. This one here is a hexagonal pyramid, right? 1, 2, 3, 4, 5, 6. So its base is a hexagon. Heptagonal, this one's a little bit hard to see, but this should have 7, 1, 2, 3, 4, 5. I kind of lost count. 6, 7. And a decagonal is going to have 10. But we're really going to be more concerned with rectangular prisms, triangle prisms, maybe pentagonal prisms. Again, just take a look at what the base is, and that is how you would name it. Sometimes people confuse a rectangular pyramid with a square prism or a rectangular prism. Let me get that picture. Sometimes people confuse these two, but you can see that they look very different. The biggest thing about a pyramid is it's always going to come to a point. If it doesn't come to a point like this, then it's going to be a prism, not a pyramid. And the sphere, again, I think you're familiar with the sphere. It's just like a basketball, right? The world, whatever. Again, it's going to have a radius, or if it goes all the way through, it will have a diameter. And so there's different volume equations for each one of these. So a prism, the formula is the volume equals this capital B, which stands for area of the base, times the height. So now we need to know the area of the base. Well, because the base could be anything, right? I'd need to find the area of this two-dimensional base, a triangle, or the pentagon, or the rectangle. So because I need to know the area formulas, you have to kind of go back and remember what the area of two-dimensional figures are. So we did that before. So the area of a square is side squared. The rectangle would be length times width. Parallelogram, base times height. Triangle, base times height divided by 2. The trapezoid would be base 1 plus base 2 divided by 2 times the height. And the circle will be pi r squared. So it's important that you know these formulas because you have to use these formulas in order to figure out the volume. So this capital B stands for area of the base. A cylinder, the volume will be pi times the radius squared times the height. And again, the height is how tall your cylinder is. We will generally be using 3.14 for pi. A pyramid is 1/3 the base times the height. So the pyramid and a prism have some similarities because it's still base times height, area of the base times the height. But a pyramid is 1/3 of that. Because it comes to a point, obviously it's going to have less volume. So you could either say 1/3 the area of the base times the height, or you can take the area of the base times the height and divide it by 3. And we'll do some examples. A cone is very similar to a cylinder, so they have some similarities because it's the same exact formula, but it's 1/3 of that. Because again, a cone comes to a point where a cylinder does not. And then a sphere is 4/3 pi r cubed, or you can write it as 4 pi r cubed divided by 3, whichever is easier for you. So let's take a look at a couple of examples of these, and let's do them out. So part A here, it says find the volume of the following polyhedron. And again, I've listed this as a polyhedron, but it's not really a polyhedron. So let's take a look at this. The first thing you have to decide is what is its shape. Well, it comes to just a point, so it's either a cone or a pyramid. The base is a rectangle, so it can't be a cone. So this must be a rectangular pyramid. So if it's a rectangular pyramid, I'm going to look up my formula. Let me get that sheet out right here for my rectangular pyramid, and it's the area of the base times the height times divided by 3. So the area of my base, well, my base is a rectangle, so the area of a rectangle is length times width. So I'm going to take 10 times 8. So the volume will be 10 times 8, which that's going to be the area of my base. And then you see here the height, which is how tall it is 7. So I'm just going to take my calculator. Oh, and of course I have to divide it by, I forgot that. Because we're talking about a pyramid, I now have to divide it by 3. So I'm going to take that and divide it by 3. So I'm going to take my calculator. I'm going to go 10 times 8 times 7, and then divide that by 3, and you'll get 186.7. And remember now, because you're talking about volume, it's always cubic units. So this will be inches cubed. So that's A. B, again, first thing you have to do is decide what shape it is, because you don't know what formula to use until you know what shape it is. Well, it has 2 circular bases. They are parallel, so it's either a prism or a cylinder. The bases are circles, so it's a cylinder. So let's go back here and find out the formula for the area of a cylinder. Is the volume is pi r squared h. Let's go ahead and look to see what variables we know. Well, we said we're going to use 3.14 for pi. It gives us here that the radius is 4, and they gave me the radius, not the diameter. And the height is the length that joins the 2 bases, so that would be 15. Again, we're just going to go to our calculator. 3.14 times 4 squared times 15. And I'm going to get 753.6. And once again, my units are feet, so that's volume, so it'll be feet cubed. Okay. Let's do C. You take a look at C. Well, that's kind of obvious. It comes to a point. It looks like an ice cream cone, so we know it's a cone. So if we look at our formulas for a cone, it's pi r squared h divided by 3. Pi, we said we're going to say, is 3.14. They give us the radius here is 6. We're going to square that. The height, which is from the center of the circle to that point, is 15. And then we're going to divide that by 3. So 3.14 times 6 squared times 15. And I'm going to divide that by 3. And I will get 565.2. Again, the units are centimeters, so that'll be centimeters cubed. On D, that one has 2 parallel bases that are rectangles. So I know that this is a rectangular prism. The formula for a rectangular prism is the area of the base times the height. And I know because it's a rectangle, the area of the base is length times width. So the volume is really going to be length times width times height. Well, I know the length and the width are 6 and 8. Whoops, 6 times 8. And the height is 15. So I just have to multiply those together. 6 times 8 times 15. And I'm going to get 720. The units are yards, so it'll be yards cubed. And E looks a little different, so we really have to think about E a little bit. So we have a base that is a rectangle. But if I look on the sides here, they're all rectangles going on the sides. And here I have a triangle, which is parallel to that other triangle. So because I have two parallel triangle bases and all the other sides are rectangles, this is actually a triangular prism. And this is where kids sometimes will call this a pyramid, but you see it can't be a pyramid because it doesn't come to just one point. So this is a triangular prism. So once again, we'll have to use the volume formula for our prism, which is the area of the base times the height. And if we look here, the area of a triangle is the base of the triangle, the height of that triangle divided by 2. Then we have to multiply it by the height of the whole prism. So the base of this triangle is 5. The height is 12. And again, now I'm only looking at the little triangle. I'm not looking at anything else, just that, just the base of this triangle. So this is 5 and 12. So it'll be 5 times 12 divided by 2. And then the height of the prism is always what's going to join those two bases. So this 9 meters is what joins those two bases. So I'm going to multiply that by 9. So I'm going to have 5 times 12 divided by 2, and I'm going to multiply that by 9. And I'm going to get 270 meters cubed. And F is our sphere. Again, not really a polyhedron. And the sphere formula for volume is 4 pi r cubed divided by 3. So 4, remember for pi, we're going to use 3.14. And now I need the radius. Well, if you look at this, they've given me the diameter. They've given me 16 all the way across. A radius is only halfway across. So if the diameter is 16, I know the radius has to be 8. So this will be 8 cubed all over 3. Go to my calculator. 4 times 3.14 times 8 cubed. And I'll divide that by 3. And I'll get 2143. If I round it to one decimal place, that'll be 0.6. And again, it's volume, so it'll be feet cubed. All right, I think I will do the pre-test on another video. I think that at least gets you started, and let me know if you have any questions.